Hello there. In this video, we cover the topics of importation and exportation, of course, in R, our new favorite programming language. So the idea here is pretty simple. R is a great tool to analyze data, but of course, we first need to import our data into R to start, well, manipulating it and analyzing it, doing all sorts of things. Now, there's many functions to import data into R. So here we will present two. Read table, which is the general one, and also read.csv, which is more specific for CSV files. And so both of them are widely used to import. Well, here we call this just text files, but I think often is going to be Excel files or files that are have the extension .csv. Okay, but just a note that there's many other functions that have slightly different use cases, but here we don't cover them. So we start with read.table. I think it's always better to start with an example. So here we have a very simple text file that contains a data set, a very simple data set, only 4 subjects, and for each of them you have 4 variables. So this text file, you can find it on ed, for example. It really looks like this if you open it. And now our job is simply we want to import it into R. Now in this specific data set, every item is separated by a comma. So name, comma, age, comma, blah, blah, blah. And then those are the names of our variables. And then after that, you have the first row that corresponds in this example to a given individual. And again, after his name, you have the comma to give you the second variables, which is the age and so on. And the fact separation is made by a comma is important when we import. We need to know this. So based on looking at the data, now we know what arguments we will need to import it using this function read.table. So here we have a summary of the main arguments of this function. Now, if you use the help tool in R to find information about this function, you'll see there's many more arguments, but really most of the time you don't need those additional arguments. But so the main ones are here. The first argument is simply the name of the file. Now here we say location of the file to be read. So where the file is located on your device, but then also including its name. Now, you don't necessarily need to specify the whole path on your computer where the file is if you work out of your working directory. Now, you don't know yet what is a working directory, so I'll explain it in a second. But the first argument is simply telling R, okay, where is this file and what is the file name? Second important argument is header. Now, by default, this argument is set to false, which means the data starts straight away without names, without a header for the names of the variables. I think most of the time your files will have a header, so you would set this to true. So for example, if this is our file, header should be put to true because we do have a header in the sense that the first line is not the first line is not the first individual. The first line is simply the names of our variables. But so careful here, header is set to false by default. So if you want it to be true, you need to type header equals true when you call the function. And again, we'll present an example in a second. Now you have this other important argument, sep. And by default is set to this thing, quotation marks. Now, this tells R what is the separation character in the file. So for us, in this specific example, the separation character would be the comma. So R would need to know, okay, whenever I have a comma, that's a different row. That's a different row because it's a different, well, it's a different variable that I have. Okay, so John is the first variable name for the first subject, but after that there's a comma. 34 means it's now in the second column, so the second variable for the first subject here, John. Now, the default here, those quotation marks means a white space. Okay, it means a white space of whatever length. so it's quite common in data set that data is not separated by a comma, it's separated by just a white space. So whenever there's a white space, it means I'm changing columns. Now this, this is not the case in this specific file. So if we want to import this specific file, we would need to change the default argument. Well, we would need to not use the default argument, which is this quotation marks. We need to use comma. So we would need to type quotation mark, comma, quotation mark. And again, we'll see an example in a second. Okay, you also have other possible separation would be the tabulation, which is just on your keyboard. There's a tab key, but I really do feel that either a white space or a comma are the most common ones, common symbols to tell R, okay, this is a new column, a new variable. Okay, and lastly, this one, I don't think you're going to use it too often, but for your information, in English, of course, the decimal, well, the symbol to indicate that a number is now in the decimals is obviously the dot, right? So 3.5, that's how it works in English. But in some languages, such as French, we actually don't use, I say we because my native language is French. For some reason, it's not the dot, it's the comma. Okay, so if you have a data set where the comma means that we start with the decimals, well, you need to tell R, okay, the decimals are indicated by a comma. But again, probably for us, the default, which is the dot, is what you need. Okay, so again, if my data set, which in this example is called mydata.txt, if it's in the working directory, then the following command will work. It will import this data set into R. So read.table is a function. My file is named mydata.txt. And notice here we do need the quotation marks. If you just write this without quotation marks, it's not going to work. So file, quotation, name of the file, header equals true, and separation equals the comma. And again, the comma needs to be between those quotation marks. Now this imports the data, but we need to put it in an R object. And we do that simply by, this is an arbitrary name, so I'm not very original here. I just call it data. So inside data, I'm going to put my imported data set. So this should work. Again, if my data is already in my working directory. And so if you do this, data will be a data frame containing the data set you imported. So yes, I don't need to specify that I want a data frame. By default, when you import from an external file, R is going to create a data frame with this new data. And once imported, note you can visualize the beginning or end of your data by using head data or tail data. Now in this example, that's not too relevant because we only have 4 rows. But if you had a big data set, head data would give you only the first 6 rows so you can visualize what this data looks like once you've imported it. Okay, now we do need to explain this business of working directory because it tends to cause some confusion among students. So first off, a directory just means a folder on your computer. Okay, so maybe you're working out of a specific folder that has this path on your computer. Now, the working directory is the folder on your computer that R is working from. So this is a specific folder where R is looking for stuff, looking for a data set, for example. And you can set, of course, you can set what your working directory is. And so in general, you want the working directory to simply be where your specific R script is, where your data files are, so where you're working from. For example, if you're working on your assignment for this course and your name is Jose, well, you might create a folder that's called assignment located on your desktop and a subfolder ACTL1101. And this is where you're going to put your script, your main coding script for your assignment, all your files, data sets, for example, and then you would want this to be your working directory. So maybe this is sound a bit abstract. Let me show you a command in R that I believe is not presented on this on these slides, but you can type get working directory, and this is going to tell you, okay, right now, what is your working directory? So by default, there's going to be some working directory. So if I type this, I'm going to get, okay, for some reason, right now, my working directory is this. But now you can set it explicitly. So back to my slides, the command set working directory. Here, if you enter the whole path, and careful here that you need a forward slash. I don't know why, but that's how R works. It wants forward slash. You will set explicitly a working directory. And once you have done this, if your file, again, for example, this my data text is in your working directory, then this command will import it. So let's illustrate this with an example. So I'm going to open here. So I think, okay, so this is in fact my working directory, I believe. Let me just go back. Yes, so R told me that's my working directory. Now, let me just for a second, okay, I had previously created my first R script, but let me show you. Let's say that I want to create a new R script. So I'm going to do just this from RStudio. So again, remember your R script is where you're going to put your code that you can save and then open later, right? So I'm not going to create from the console. I need to open the source. I believe I can click here and then I get this window. Now here I'm going to type that would be my second R script. Okay, and from this script, I'm going to try to import data. So now it's not saved. So right now this file doesn't exist basically. So I need to save it, and now I'm going to go save it wherever I was already working from. So here I'm going to call it my second R script. Very exciting. I'm making progress in R. Okay, so now this file exists, and I haven't written much in it, but just to show you what happens if you try to work, say, outside of your working directory. So imagine that I want to import this my text file. Now you noticed maybe from before, I've put ahead of time my data. This is the file mentioned in the slide, my data.txt. But now let's imagine I remove it from my working directory. So I'm going to put it somewhere else. Maybe I'll put it. Actually, I don't know where. I'm going to put it on my desktop for a second, right? So it's going to disappear, but I've put it on my desktop. So now it's not there. So if I go to my my new script, my second R script, and I try to use the command given in the given here. So I want to read this data set. I'm going to copy this. Now, will this work? So if I create, let's say, my data, I think you can guess that it's not going to work because, again, this file is no longer in my working directory. So if I do this, it doesn't work. It doesn't work. Now it's on my desktop, so I can probably specify if I go to my desktop here. This is the path to my desktop, and you see my data is there because I just moved it there. So if I go back to RStudio and I type the whole path to my desktop. Now, again, there's this slightly annoying thing that R wants. Let me just make this bigger. R wants forward slash. So when you copy from a whole path on your computer, the default is a backslash, but now I need to change everything to forward slash. But aside from that, it should work. So you see here, I've specified the whole path where my data is. So I'm going to execute this. Should work now. So yes, I don't get an error message. And after that, again, if I want to display this data, I can type head, my data. Well, actually, this is a small data set, so I can just type my data and it's gonna display. So again, I select this, Control Enter, and I see, voila, my data is there. But you see, I haven't exploited the fact that my text, my data.txt is in my working directory. So now let's show the other way. Again, what is my working directory? You can type get working directory, which again for me is the OneDrive, then documents. So let's bring back my data to the working directory. So I'm going to put back my data.txt here in what is currently my working directory. So if I do that, let's just erase my data for now. So you see my data is loaded in my RStudio session. So it exists, but I can erase it. So if I click this, I believe that's a little broom. I'm going to clear objects. So yes. And you see now my data no longer exists. So if I type my data, I've just erased it. So my data not found. So why did I do that? I just want to show you that now, because my working directory is this whole thing, not the desktop, sorry, the path given there, the OneDrive, sorry, where is it? OneDrive documents. I don't need this whole thing. Okay, I can just type read table my data because R is already looking in the folder, which is the working directory where my data text is. Okay, so I'm sorry if I'm repeating myself, but just to make this clear, right now my working directory is this folder, and my data, the file my data is there. So if I type this command, it should work. Yes, I'm just reading the name of the data, and this data is in the working directory. And so R finds it, and it's happy days. Okay, just to show you, you can use head now just for a change. Again, head gives you the first couple rows of a data set, but in this case, it's going to give all of them because it's a very small data set, only 4 people. Okay, hopefully that wasn't too confusing. And again, if it is, you need to pause the video and try this for yourself, and maybe a bit of trial and error, you'll figure it out. But again, the main things are to find your working directory. You type get working directory, and to set explicitly the working directory. You can, well, there's 2 things. You can use set working directory, and for example here you could type whatever folder where your files are. But there's a shortcut that is not presented to the side, so I might as well give it to you now. So again, right now my working directory is the documents one. In R, if you go to session, set working directory, you can choose explicitly a directory. Well, you can actually, this is quite useful to source file location. So the current file that is open, you can type to source file directory. Now it's going to choose as working directory where the file is located. So that's a good behavior if you want to do that. But you can also choose it explicitly. So choose directory. It's going to open your folders, and then you can choose, okay, whatever. Now, for some reason, I want to work out of my desktop, so I'm going to choose the desktop. And now I have a new working directory, which is my desktop. And again, if you followed, should this command work, read table? Well, no, because my text data is not on my desktop, which I just set to be my new working directory. So R is always looking for files in the specified working directory. Okay, I think that's enough about working directories. If you're still confused about this, again, trial and error, or ask us questions on the discussion forum. And actually, okay, now there's actually an exercise for you. So I'm gonna review this, but I do suggest you read this whole thing and you try to do it yourself before my explanations. So, and by the way, we put this file on ed, this file Danish Fire, so you can try this in ed, but I recommend do it actually on your own computer. Do it out of RStudio, because in reality, you're going to use RStudio. So this file is the one I want you to play around, and the goal is to import it. So it's called danishfire.txt. I can show you just quickly in ed. It should be there. So in your week 2, you have your exercise space here. In there's this is the script, but you have files. So the files, well, my data is there and Danish Fire is there. But again, I recommend you try this and try to import it to your RStudio rather than in the ed space. I mean, you can do both. Okay, so this file contains claim amounts for 3 different categories of insurance losses, and also with the dates at which the losses occurred. Now, a function I haven't presented, so it's given here, is read lines. So read lines, careful, it reads the data and shows it to you in R, but it does not import it. So this is just to visualize the data. And once you visualized it, then you can probably use the fact you've seen the data to choose the arguments of your function read table. Okay, so yeah, as I said, at this stage, you're just looking at the data. You have not imported it. Now, the task for you is to import the data and store it in a data frame that you can call Danish_fire. So careful here, this would be the specific name of the data frame in R once you've imported the data. Don't confuse this with the actual name of the file you're importing. display the first few rows using head, apply functions class, structure to Danish fire, and then check what kind of useful information this gives you. And lastly, you can start doing a little bit of analysis here. We ask you just for practice, can you find the mean of the building losses? So building losses would be one specific column in this data set. And can you find the correlation between the building losses and the contents losses? Now, correlation, we haven't covered this yet, but just for practice here, we give you straight away, this is the core function you can use to find the statistical correlation between two numerical variables. Okay, so again, try to do this on your computer. Pause the video, try to do that. Okay, so the commands to do this are here. Again, let me just show you well, the commands are there. This really should be the result in RStudio, but we can do it quickly. So let's go back to RStudio for a second. Now, I just, now my working directory, where is it again? We're going to practice this concept. So it's my desktop. Now I don't have the files on my desktop. So again, I need to change the working directory back to what it was. So let's just, okay, maybe I'm going to save this. Now, let me show you the function of setting the working directory to the current file location. So you see, my second R script is here, and Danish Fire is in the same folder as my second R script. So what I could do here is go to Session, Set Working Directory, to Source File Location. Again, the source file is the script that's currently open. So if I click this, you see it's setting the working directory to where the file is, but which is in this case what I want, because if I type get working directory here, I'm back to my documents, which again, documents is what I have here, where Danish Fire is. So if I do that, I can, let me just put a comment here, import Danish Fire. And I can try the command that are on my slide. So first one is read lines. So again, read lines does not import the file, it just visualizes it. So out of RStudio, read lines will just show me the data. So now I can see, okay, there's this first variable. I don't know why it's called positions, because it's for the dates, but then I have my three numerical variables for those are insurance losses, and I also have the total. So I have 5 variables here in this data set. But now I do want to import it. I don't just want to see it. So in this case, I'm going to import it like that. So you see, because I visualize my data and I see it's not separated, so columns are not separated by commas, they're separated by a white space. But the white space should be the sep argument set to just quotation marks. Now that's the default, so I actually don't really need it, but for the sake of illustration, I'm putting it here explicitly. And my data does have header. So you see the first line gives me the names of the variables. So I do need to put header equals true, and this should work. So I execute this line, and then I show the first couple rows. That's a bigger data set. It has a couple thousand rows. So I don't want to display the whole data set. I just want to see the first few rows to make sure, okay, it looks like it's worked. Danish Fire does look like a data frame with, well, different columns for different variables. So that's good. Now we ask you, what does class do? Well, class will tell you what data structure it is. So in this case, as I said, when you import data, it's going to by default be a data frame. So you see the class of Danish Fire is a data frame, which is the behavior I want. Usually you want the new data set to be a data frame. Again, because data frame allows for different columns to be of different data types. For example, this is a date, while the other ones are numerical. Okay, then structure of Danish Fire will give you basic information. So, okay, you can try this in RStudio, but this is what it's going to display. It's going to tell you quite useful. Okay, you have 2,167 observations of 5 variables, and then gives you the first few. So again, this you can use to visualize, okay, the first few observations of your data set, and it tells you, okay, the first one, it's actually not a date, is set to the character data type, but then the other ones are numerical. Okay, and lastly, the sort of small statistical calculations you can do is mean of Danish Fire. So let's just practice this in RStudio. So maybe I put a comment to say this is calculations. Again, recall that you can extract a specific variable from the data set by using the dollar sign syntax. So you see, the second variable is called building. So Danish fire, that's my data set, dollar sign building extracts the, in this case, the mean, because I applied the mean to this whole thing. So the mean of the building variable is this. I think it's, well, it's Danish, right? So I think it's in millions of Danish crowns, I believe, is their currency, although don't quote me on this. Then you can do other fun stuff. Maybe a visualization. Maybe you want to check the histogram of the Danish fire building. So, okay, histogram is extremely skewed, so it's not that helpful, I suppose, in this case. But maybe you can have the histogram of the log of the losses. That should be more normal. Okay, well, it's not exactly normal, but okay. I'm just going on tangents. And then the other thing was to find the correlation, right? Correlation between building and something else. I forget now. Yeah, building and contents. Okay, so contents is another variable in this data set. Okay, so you find the correlation between the building loss, insurance loss, and the contents insurance loss, which here is positive. I suppose that makes sense. And then that's good. Now, just a comment here, but I think I said it. Function read lines is useful as it allows you to visualize the beginning of the data before you import it. So you know the structure of the data and can determine the arguments of the function. So yes, indeed here, because I had checked what my data looked like using read lines, I knew I needed to use the default separator, which is just the white space, and I knew my data had header. Okay, then to import data, there's other functions that can be useful to just simplify the syntax a little bit when you have default formats. So for example, if you have a standard format that is CSV, well, most of the arguments in read table would be fixed. They have a specific value because the format is specifically CSV. So in the case of CSV, it's comma separated value. So let's just see an example. Well, the function we're going to use to import a CSV is read.csv. Now, to be clear, you could use read table. You could use read table still. So, but read CSV is going to simplify your syntax a little bit because you don't need to specify some of the arguments. In fact, most of the time, if you have a CSV file and you use read CSV, you don't need to specify any arguments because read CSV header is set to true by default. And usually most CSV files will have a header. And of course, the separation is set by default to be the comma. So in reality, read CSV often just works by typing the name of the file. So in this case, again, if this file movies.csv is in my working directory, I can just call read CSV name of the file, and magically my file is going to be imported in R. Again, this syntax means that I'm creating a data frame with the arbitrary name. Here I just chose movies.data, in which I place this data set. And again, here it's a data set of movies, but in fact, whoever created this data set, not me, is a huge fan of Harry Potter movies. And in fact, this whole data set has only 8 movies, all the Harry Potter movies. Now remember, head only gives you by default the first 6. But so there's basically two more that we don't see here because we used head. And I believe that's it. Maybe you can try that. This works for you as well. Again, this movies data set is found on the Ed forum. Am I being lazy here not to do this in R? Actually, well, let's do it because it takes a second. So I go back to my R studio. Am I in the correct working directory? So import Harry here. What's my working directory? Okay, that's fine. That's the correct one. So if I do this, I'm going to import my movies. Now, again, there's only 8 movies here, right? So if I can easily visualize all of them by just typing this. Okay, here, let's do it again so that everything displays more neatly. Whoops, what happened there? I think did I make a mistake somewhere? Okay, so I see everything. You see there's only 8 movies for the 8 Harry Potter movies. Well, there were only 7 Harry Potter books, right? But I suppose film studios got a bit greedy and decided to make 2 movies out of the last book, right? To pocket all this nice box office profit. So anyway, here you have it, all the Harry Potter movies with some information about their budget and box office. And you see, the point here is I didn't need to specify any arguments because by default, read CSV as header to true. And here I do have headers for my movies. And of course, separation is the comma. Okay, so I think it's fair that most data sets you will come across are actually CSVs. They're certainly not all, but it's very, very common. So read CSV is going to be is going to do the trick most of the time. That said, it's important to be comfortable with the more general read table. For example, if you have a data set that looks like the Danish fire one, where it's not the separation of different observations is not, or different variables, I should say, it's not the comma, it's the white space. Okay, and then lastly, so this was importing data. Now the other thing is often you're going to make analysis inside R, create new variables maybe, or something, I don't know. But then you want to export. So you've created a new data set in R and you want to export it so that other people can use it. For example, as a CSV file or other types of files. So to do that, you simply use the write table or write CSV. So they're kind of the equivalent of the read table and read CSV, but for exportation. So you're going to take a data set you've created in R and then export it to whatever format you want. The general function is read table, but then the one for CSV is write table, and then the one for CSV is write CSV. So let's just cover a small example with this. Create a data frame that contains only the first 50 rows of Danish fire, and then export this new data to a folder on your computer. So, well, the example is there. Let's imagine that, okay, Danish fire, I've imported it, and then I made some manipulation to it, and I want to export it again with my changes. In this case, it's simple example. I just want to grab the first 50 rows, right? For whatever reason. So then I create a new data set, Danish 50 only. Now notice the syntax. It's grabbing only the first 50 rows, but it's grabbing all the columns. Maybe you can just double check that this works. So exporting here. So Danish 50 only. Okay, that should work. And again, well, maybe 50 is still quite a lot, but maybe you can still display all of it. You see, I've grabbed all the rows, including the header, up to the 50th observation. I mean, and maybe interesting to know that this notation, you see, it really is going to grab the first 50 observations, right? But so the header doesn't count as the first observation, again, because it's a header, it's the name of the variables. Okay, and then I want to export it. So export to a text file, so I can use write table for that. Okay, for some reason, I'm going to choose a tabulation. So let's see what this does. Tabulation as separation. Now you see, I think you can guess that if I do that, so this is the name of my data set. Now that's the file I choose. So I can call this whatever I like. Here in this case, I'm going to call it myfile.txt. And I think you can guess if I do that, it's going to create a new file. So export my new data set, but specifically to the, did this execute? Or I just deleted it? Okay, this should have worked now. It's going to export this data set, of course, to my working directory. So again, for me, the working directory is this. And did it work? Yes, because it's 1049. I created this new file that has been modified at 1049. And so if I open it, hopefully it should have worked and created a new data set where you see the separation is a tab. So a tab is kind of a bigger white space, basically. And so I have here my 50 rows of data. You can do the same thing by creating a CSV by just changing here CSV and here write.csv. And now I don't need a separation argument because, of course, CSV is going to be a comma separation file. So again, this should create a CSV called my file at 1050. If I open it, by default, it should open in Excel, but you could open it in other software, I suppose. And I'll be able to visualize my file here in Excel, which is obviously excellent. Pardon the pun. Okay, I believe that's the end of those slides. Okay, there's one last comment that obviously this is going to create a file in your working directory, but if you want to export the file somewhere else, you can instead of just writing file here, you can specify a whole path, and then it's going to save your file in whatever folder you've chosen. Try it out for yourself if you want. I'm not forcing you. It is a free country after all. Okay, that's the end of the slides. There's some homework exercises. And I believe, yeah, after the homework exercise, there's some extra slides here that I call them additional notes, so you can review them if you want. I suppose I view them as not unimportant, but maybe slightly less essential than the rest. So anyway, I'm not going to cover them, but they're there for your information. Okay, I'll stop here. Thanks so much for having listened to this. And if you have any questions, of course, send them my way. Bye for now.